In this section, we're going to learn about scaling resources in Azure App Services. Given all the capacity available to us in the public cloud, scaling, sometimes referred to as bursting, has become a great mechanism for optimizing costs and ensuring the performance of your application. The ability to scale a web application is what gives us the flexibility to handle dynamic workloads in a cost-effective manner and becomes an example of where the cloud really starts to make sense. Scaling to handle increased workload comes via two ways. We have the ability to scale out, also sometimes referred to as horizontal scaling. It's when you need additional virtual machines or instances to run your application. By scaling out in this instance means we're adding additional app service plans. So as one does not become enough to handle the workload, we can add 2, 3, or 4. We can scale all the way up to 20 instances depending on your pricing tier. Another way we can do this is what's called a scaling up, and that's essentially adding more resources to an existing app service plan. We can do this by changing the app service plan tier. So in this instance, you can see we're adding more resources, so we're adding or scaling our tier up within the existing app service plan. When it comes to scaling, there are a few different approaches that we can take. Understanding your workload will help you determine the proper way to scale your application or scale your resources. For example, if you know your application will exhaust your memory long before the CPU utilization becomes a bottleneck, it makes more sense to scale based on the amount of memory available versus the CPU utilization. Let's take a look at a few of the approaches that are available. We've got the scale based on an infrastructure metric. This would be something like CPU utilization or memory utilization. It's very simple to configure, but sometimes you might not get the best results because we're looking at one metric. Another approach is scaling by an application metric, and this could be something that's gained by using application insights. And rather than looking at just specifically CPU or memory utilization, this could give us a performance-based metric to see how long does a page take to load. If the load time goes above a certain threshold, then we know we're potentially running into a bottleneck, so let's have a scale event. Another way we can do this is scale to specific instance counts. Say for example, during a given period, your workload is going to increase dramatically, so rather than let the auto scale rules take into place, I'm just going to say I'm going to have an additional 3 instances running during this time frame. Or on the flip side of that, if during your off-peak hours, let's go ahead and let's scale down. We know we're only going to need 2 to 3 instances. Let's go ahead and do that rather than having to wait for those auto scale rules to happen. Once you've decided on your approach, then you need to configure your rule set. First, we need to configure the criteria for your rule. This is the metric that you're going to use based upon an action. For example, anytime the average CPU utilization is over 70% for a period of 10 minutes. Next, you decide the action to take and the cooldown period. The action could be to increase your instance count by 1, or you may more aggressively expand by 2 or 3, or leapfrog all of this and go to a specific instant count. There are multiple options you can configure here based upon your application requirements. The cooldown time is a time in minutes that will need to pass after an action takes place before the rule will be evaluated again. This ensures we don't continuously add resources without allowing enough time for the previous action to have taken effect. One thing to keep in mind as we're creating skill rules to scale out based upon various activities, we also need to make sure we're configuring a rule at the same time to scale back in. We don't want to have our period of heavy activity and scale up to meet those needs and then not have any rules to scale back in, so we have all those additional resources out there running, increasing our spend without providing any value. So anytime we create a scale out rule, it is also wise to create a scale in rule at the same time, ideally based off the same metric. Remember to take into account the session state for your web application if you're utilizing scale sets. When an instance scales down, they could be removing web apps which were previously had traffic. The next time the user connects to that external website, they'll be directed to a different instance, so it is important that their state is maintained using a SQL database or Redis cache. We talked about scaling and scale rules in this session. Let's jump in the portal and take a look at how to put this into practice. So here we are back at our web app again, and now what we're going to talk about is scaling. And remember that the web app itself doesn't per se care about resources. It will use everything that's available to it if it's needed. Since we define the amount of resources at the app service plan, whenever we talk about scale, we need to make changes at the app service plan level. So with that said, let's go ahead and open the app service plan. And let's go down here under settings to scale. So let's talk about scale up first. And if you remember, when we're talking about scale up, that's not adding additional instances, that's adding more resources to the existing instance. So with that said, we're currently at the S1 tier, which has 100 total ACU and 1 3/4 gigabyte of memory available. You can see here, while we don't have options for the Premium V2 scale units, we do have options under the S2 and S3 pricing tiers. So let's take a look here. You can see if we wanted to essentially double, we could add the S2 instance, which doubles the amount of ACU as well as memory. And if that still isn't enough, we can move up to an S3, which has, again, double the amount of capacity from the S2, or 4 times the amount that we have today available from the S1. So we would go from 100 ACU to 400 ACU, and 1 3/4 gigabyte of memory all the way up to 7. That being said, the cost jumps accordingly. So we would basically pay 4 times as much as we are right now to move from the S1 to the S3. With that said, if we needed to scale up a app service plan, this is how we would do it. We would go into the scale up setting, choose a new pricing tier, and let it run. The advantage to this is that it's a one-time change. We don't need to worry about anything else. The disadvantage to this, though, is that it's that one-time change, so that price is going to automatically increase. And even if our workload decreases, we're not automatically going to scale down to have those savings or basically realize those savings. So with that in mind, the scale out option is something that people tend to look into a little more frequently. And again, the scale out option, essentially, we're going to keep the same size or the same amount of capacity available at our app service plan, but we're going to have more instances. So we would have one unit that had, again, 100 ACU in this instance and 1 3/4 gigabytes. Or if we scaled out, now we have 2 units available. So essentially the equivalent of an S2. And then so on and so forth. So we can increase all the way up to 10 for this particular tier. So this works well if you know that you've got a increase coming and you want to manually do it and don't want to worry about Azure handling that. However, one of the benefits of the cloud is automating this. Let's take a look at auto scaling. So if we select auto scaling, we have the option now. We can give it a rule name. And then we have a couple different options. We can set the scale mode, which basically means Azure is going to look at a given metric that we define, and if it exceeds a threshold or drops below a threshold, we're going to make a scaling decision based upon that. Alternatively, you can scale to a specific instance count based on a schedule. So you could define a schedule that says between Monday at 7 a.m. to Friday at 5 p.m., I'm going to scale up, and then during the weekend I'm going to scale down. Or you might have that just during business hours or however, but that gives you the ability to essentially manually scale, but on a schedule, and have the process be automated. We're going to look at scaling based on a metric in this instance. Let's go ahead and leave the default of scale based on metric, and let's go down to add a rule. So similar to what we looked at in the PowerPoints, you can see here we've got a scale rule. And we can do a couple different criteria, the average, count, max, min, so on and so forth. We'll leave it as a default for average, and we can look at the metric name. You see here, we've got a number of these metrics available, are very similar to what we saw when we looked at the metrics underneath the app service plan. We're going to leave the default of CPU percentage. So and if we scroll down now you can see where we get into the operator, or basically where we set those thresholds. So what we're saying in this instance is if the CPU utilization is greater than 70% over a 10-minute period, we're going to increase the count by 1, and we're going to give it a 5-minute cooldown period. So essentially, if our CPU threshold is above 70% over 10 minutes, we're going to increase the instance count by 1, and then we're going to wait 5 minutes. We're not going to look at anything. We're going to let that additional instance come into play. We're going to see if that addresses our workload issue. And if it does, then we're not going to do anything. We're just going to sit there and continue to monitor, but we're not going to make any changes. If we add that additional instance after 5 minutes and our CPU threshold is still above 70%, we're going to auto scale again. That will repeat until that threshold drops below 70% over 10 minutes, or we hit our maximum instance count. With that said, let's leave these defaults and we'll go ahead and click add. Now you can see we've got our scale out rule. And when the CPU utilization is greater than 70%, increase by 1. And you can see down below, here's where we've got our instance counts, our maximum as well as the minimums. Like we mentioned during the slide though, anytime we create a scale out rule, we should also create a scale in rule. So let's go ahead and add another rule. We're going to leave all of these by default because it should essentially match the same scale out rule or should use the same concepts as our scale out rule. However, instead of being greater than 70%, we're going to select the operator to be less than 20% over that same 10-minute period. And this time we're going to decrease the count by 1 with the same cooldown period. This is essentially using the exact same concept, except if the CPU utilization is below 20%, we're going to say our usage is relatively low, so we don't need all of those instances. So we're going to go ahead and remove one. And we'll go ahead and click add here. And this will continue to happen if our CPU utilization keeps dropping below 20%. It will go ahead and keep scaling down until we hit our instance limits, which in this case is 1. So again here, we've got our scale out rule for when our utilization is very high, and then we also have our scale in rule when our utilization is low. This way we're being as efficient as we can within Azure to help reduce our spend. That covers scaling within app service plans. I would recommend going through and creating a scale rule or tool, or at least looking through the interface so you understand what happens. As you take your exam, don't be surprised to see a question on the scale rules, and you need to understand if you look at a scale rule, what's happening.